Hello, I'm student 105-12748. Today I'd like to talk to you about Dynamic Host Configuration Protocol, DHCP. DHCP is an application layer 7 protocol used to allocate and configure a client's IP address. DHCP standards defined in the IETF standards. There's 2131 and 2132, plenty of information available on the internet if you want to read up about all of those standards. Today, though, I would like to give a brief, I would like to show you the process of a client requesting a DHCP address and the communication that happens between the client and the server. So there's 4 messages that happen between a client and the server: discover, an offer, a request, and acknowledge. I just got those 4 letters highlighted because DORA is the way I remember it. So I'd like to go through those 4 messages in a Wireshark capture and show you what they look like and show you the process in action. Some of these other bits down here are some of the other attributes that we'll find will also get passed with the IP address. So what I'd like to do first of all, I just want to, with this command prompt, just want to show you or give you a lay of the land where we currently sit. So there is, okay, we've got a 169.254 address now there. Now that's an automatic allocated private IP address. Basically, we've got no connectivity at the moment. That's not a usable IP address if you want to get anywhere. So what I'm going to do is I am going to just get rid of that. I'm going to start up my Wireshark trace. Here, I click on my Wi-Fi. I'm on a Wi-Fi network now. I'm not physically plugged into the network. So that has now started capturing traffic. And what I am going to do now is back to my command prompt. I'm going to issue the command ipconfig with the option renew. Now what the renew will do, it'll kick off the DHCP process. The client will actually issue a discover message, and hopefully our 4 messages will start processing. So I'd just like to run another IP config now. We'll just have a look and see what this is showing us. So we can see now, we now have a 10.1.1.221 IP address allocated to this PC. We now have connectivity and we're off and running on the network. So that's done now. So what I'm going to do, I'm going to stop that traffic, the capturing of all that traffic. We've captured 1,459 frames. Now I want to look at just DHCP traffic, so I can click on the sort, and actually there it is there. There's our information there. Probably another way a better way, or in my view, a better way is just doing a sort or a filter, adding a filter for UDP port 68 or UDP port 67. These are the ports that that DHCP uses. One with the client and one with the server. So if we do a filter on either of those, we'll get just our DHCP messages. So what we have here is we've got, okay, so we've got 2 discovers. Yep, interesting. Okay, so the first discover, it looks like UDP by its nature. If it sends a message and if it doesn't get something back in the expected time frame, it'll just drop that and it'll just retry. So I'm assuming that's what's happened on this occasion without looking into it any deeper. There's our D, Dora, discover, our O, our R, and there's our A. Now we have got another O there. I've been practicing doing a couple of trial runs. I don't understand why that is coming up. I've Googled it. Maybe by the end, and I've got my master's, I might be able to explain it, but at this point, I'm just going to have to ignore that. So hopefully you can do that with me. Okay, so what I'm going to do first is jump in to this DHCP discover. So remember when I issued the renew command, that renew is kicked off, and what it's done is it's actually sent out a destination. So this is our MAC address, the source address and MAC address here, and this is a broadcast address, as we know. So a broadcast message would have been sent out to all the devices on the physical local physical subnet. So it would have gone out there. It's gone. And this is all the information that was sent out with the discover message. All this down here. Oh, okay, this is interesting. So this is the requested IP address. So a client, if it's had an IP address, it can actually request the same IP address again, which is what it looks like it's done on this occasion. So it's requested 10.1.1.221. If it's not available, it won't be given it from DHC, but it can request it. Okay, so that's that first discover. It's probably the one other one I wanted to show you was, here we go here. So source port address 68, and it's sending out on destination port address 67. So the DHCP server should be listening on port 67. And we can see that it was, because we've now got our offer message, which has come back from the DHCP server. So you can say now the source address 67 and the destination is now 68, which is our client again. So what it's done here, you can see down below here. So it's gone and said it's now starting to populate some of this information here. It's saying, look, this is a DHCP server address. All of these values here. We've got a, what else have we got here? We've got a IP address lease time. So it's a 1 day, 24-hour lease of the IP address. So unless that's renewed before that 1 day, then this IP address will no longer work, and the client will release that IP address, and the process will need to start again. But what also we have here is a renewal time of 12 hours. So that is actually just half whatever the value here. That's half of it, and what it'll do after 12 hours, it'll actually go, okay, I still want an IP address. Can you actually go and issue me another one? And if that process occurs successfully, then it will be given that IP address for another 24 hours. So it'll just push the time out. And then there's a lot of other sort of information that we talked about probably right at the start, your default or your router address. You see all these are 10.1.1.1, so it would indicate that your DHCP server, your DNS server, which is down below 10.1.1.1, they're all on the same device, and that is the case because I've got an IONET router, which is the DHCP router and your default gateway, and does a lot of different functions. So there is we've had our D. Now this is our offer that's come back from the DHCP server. Now we've got the request. Now the request is back from the client. It's received all that information, and now it's got that, and it's basically just sending all the information back again and saying, yep, I want to take you up on the offer. That's what I want to do. So it sends that back to the DHCP server, and the DHCP server picks that up, and it says, yes, that's what you can have. It acknowledges. It hasn't actually given the IP address at this point. But this is the last message it sends back to the client. The DORA, this is the A message, acknowledge. It'll send it back. Here's all the information that's still in here. Nothing's or maybe something's changed. I can't see anything major that's changed. So all of the information that was originally offered is now set, and it's been given it in the acknowledge. So the client will then pick that up, and we'll use that to configure its IP address. So we've got that down. So what I'd like to do now, we just jump on here, back onto my command prompt, ipconfig/all will just give us a little bit more information. Now we can start seeing, there's our 10.1.1.221. That was the requested IP address that we saw. It's got our DNS servers, which we saw down here, 10.1.1.1. All of this information will match up in here. So hopefully that's been helpful, and hopefully that explained the process for DHCP and the 4 DORA messages that happen between the client and the DHCP server. So thank you for your time.